Welcome back, everybody. This video we're going to be talking about just different types of sequences. Alright, on this first one, we'll say what type of sequence is this? We have 3, 4, 5, 6. So basically, each time we're just adding 1. 3 plus 1, 4 plus 1, 5 plus 1, and so forth. So we would call this an arithmetic sequence, as opposed to a geometric one, when you multiply or divide by something each time to get the next number. So this is arithmetic. What type is this? So we go 4, 9, 13. So we go up 5, and then up 4, and then up 5. Okay. Or actually up 9. There doesn't seem to be a consistent pattern. So we would say neither arithmetic nor geometric. Yeah, if there's no pattern to it, we just say neither. Alright, what's the pattern? Okay, we're going 5, then -1, -7, -3. So look, each time we are subtracting 6 each time. To get the next term in the sequence, we take away 6. So sometimes you have to identify what's going on here. Okay, so here we are. An arrangement of marbles has 12 marbles in the first row, 10 rows in all. Each successive row has 1 marble added. What's the explicit rule for this situation? How many marbles will be in the 10th row? Okay, so we have row 1 will have 12 marbles. Row 2 will have one more than that, 13. Row 3 will have 14. Row 4 will have 15, and so on. Now, if we label, we're going to go all the way to the 10th row. And so we got to figure out how many marbles would be there. Well, the explicit rule. So whatever term you're looking for, the nth term, that's what the little subscript means. If you look each time from 1 to 12, 2 to 13, 3 to 14, 4 to 15, we're taking 11 and we just add 11 to whatever one it is. Okay, so we can test this out. So let's say the third row, isn't that right? We take 11 and then plus 3, and that equals 14. And notice that's what we get. We can apply this for any rule. So say we want the 10th term. We're going to do 11 plus 10. And that's going to equal 21. So our explicit rule is right here. How many marbles in the 10th row? 21. Okay, let's try another one. Ryan starts his card collection with the 195 trading cards in week 1. Each week after this, he purchases 16 more trading cards. How many trading cards will he have after week 12? All right, way to look at this. So the first week, A1, we say he has 195. All right, the explicit rule, so any given week, he'll always have that 195, but then we add 16, depending on how many weeks have passed, to signify that n minus 1. Okay, the reason we do n minus 1 is because this will account for the 195 being the first week. So check it out. Say we did the first week. Say we did the 1. That would be 195 plus 16 times 1 minus 1. And 1 minus 1 is 0. 0 plus 195 is 195. So that holds true for the first week. But we're interested in week 12. Alright, so this rule is 195 plus 16 multiplied by 12 minus 1. And isn't 12 minus 1 11? We do 11 times 16 to get 176, and we're going to add that to 195 and get 371. So by week 12, he has 371 trading cards. All right, look at another one here. This is just straight up, what's the 12th term of the sequence? The nth term is -16 plus 2n. So if I want the 12th term, I take -16 plus 2 times 12. 2 times 12 is 24. -16 plus 24 is 8. 8 is the 12th term of this sequence. Alright, let's go to our next problem here. It says there are 1,000 residents in the town in year 1. That number increases 1% each year. What's the explicit rule for the number of residents, and how many residents will it be in year 10? Okay, so here is our, here's like a basic formula for this. Capital A starting amount, 1 for, this is exponential growth. 1 plus the rate, and then we do n minus 1. Okay, so let's get this rule here. 1,000 residents year 1, the number increases 1% a year. What's the explicit rule, and how many residents in year 10? Here's our explicit rule. Our initial amount is 1,000. 1 plus the rate, we have to list rate as a decimal, 0.01. And then we're raising that to the n minus 1 power. Alright, to find A of 10, or the year 10, start off with 1,000, first year, 1.01, showing that growth, and 10 minus 1 is 9. Alright, and then I think we get a decimal, 1,093 point something. We're going to round it up. Here's our explicit rule. Calculator's going to show 1,000, rounding up, 1,094. Round 1,094 in year 10. Alright, let's look at the next one here. Mary's playing a video game. She earns 15 points as she completes level 1. Each time she completes a level, she earns twice as many points as the previous level. How many points will Mary earn when she completes level 8? Alright, so here's our first level. She gets 15. So think of this sort of like this is an exponential or a geometric sequence. The nth level, 15, and every time it doubles 2, but we raise that to the power of n minus 1, just like before. Alright, there's our initial amount. Now we're interested in level 8. 15 times 2 raised to the 7 power, because 7 is from a plug on the calculator. We get 1,920. She'll get 1,920 points when she completes level 8. Alright, last one, another straight up problem. Term of the sequence, geometric exponential sequence. The 5th term, we're going to put 5 in for n, and that's going to be 5 times 2 to the 4th power. Alright, and 2 to the 4th is 16. 16 times 5 is 80. So the 5th term of this sequence is 80. Alright, thanks for watching. Hopefully this gave you a little overview of how to do arithmetic geometric sequences.